Hi. So today we're going to be talking about derived quantities and units. So derived quantities are those that are obtained by simple combination. I want you to note this word: simple combination of the fundamental quantities and units. So we combine the fundamental quantities that we have seen in the last video. We combine three of them to form another new quantity. So that's why it's called derived, something gotten from something. So how do we do this? Let's go. So the first quantity I want to look at is the area. I want to look at area, for instance. So we know that area is the area of a four-sided shape is length times breadth, and we know that length and breadth is that's length times breadth, and length is measured in meter. Then breadth is also measured in meter, which is a form of a length. So we'd see that gives us m times m is m squared. So the derived quantity is area. The derived unit is m squared. So that's it. Then we want to look at another quantity, volume. Let's look at volume. So the volume of a four-sided shape, that would be length times breadth times height. So say length times breadth times height. So that is length is meters, that's the basic unit for length, breadth meters, and likewise height is meters. So m times m times m, that gives us m raised to the power of 3, m cubed. So the basic unit, the basic quantity is volume, white unit is meter cube. Okay, so we want to look at density. It's another derived unit. And how do we do this? So since we have derived many of that, so let's look at mass. It's given us mass divided by volume. And from what we've learned, that mass, the basic unit for mass is kg. So that's kg divided by, what's that, volume? We just did volume now, and that's meter cube. So density has its units to be kg m raised to the power of 3, and density is a derived quantity. So let's look for another one to do. Let's do velocity, which is a common derived unit, velocity. And how is velocity derived? Velocity is derived by saying displacement, which is a form of distance, but this direction. Displacement over time. So we see that velocity, displacement over time, and displacement, I said that there is a form of distance but gives direction. Meter, that's length over seconds. So we say that is meter per seconds, and that's the derived unit for velocity, and this is a derived quantity, so match each other. Then let's do one more. There are very many derived quantity, but let's just take one more example. Acceleration. Let's take acceleration, which is another popular derived quantity. Acceleration, which we're going to be needing a lot in math. So it's a velocity over time. So what's the units of velocity? We just discovered that the unit of velocity is meter per second divided by seconds. And so if you do this mathematically, we should have meter per second square, or some people write it as ms raised to the power of minus 2 rather. Minus 2. So this is the derived unit for acceleration, the derived quantity. And so let me just show you a full table of how this should go. So we have this. So we have the area, length times breadth, and that gives us m squared, volume m cube, density kg per meter cube, then velocity meter per seconds, and acceleration, change in velocity over time, and that gives us meter per second squared.